Okay, good evening, everybody. Boa noite. Tudo bem? How are you guys? So we are going to talk in English because we would like to give this warm welcoming to the speakers from the United States. We have a special guests from other parts of Brazil, Miami. So thank you so much. We have this special webinar to talk about very important issue. So first of all, I'm going to introduce myself. My name is Sujong Ko. I am founding partner of Golden Consulting, which is an international consulting firm focused on merger and acquisition and investment. We focus a lot on Latin America and Asia. This webinar is being recorded, so if you do not want to be on the video, please just turn off the video and keep everything on mute. We are going to share this recording on social media afterwards. Before introducing our speakers, let me express my words of gratitude to some supporters. First of all, I would like to say my thanks words to BA Visa, BR Visa, for the sponsorship. BR Visa is a company specialized in visa and international mobility of people. Also, I would like to give my words of gratitude to Trade Energy. Trade Energy is a startup that connects the renewable energy producers with the renewable energy consumers. Keep Electric. Also, I'd like to say my words of gratitude to Keep Electric that imports Tesla to the Brazilian buyers here in Brazil. They have been doing very good job. Finally, I would like to say my thanks words to DM Consultoria em Treinamento, which is a firm specialized in international emotional intelligence. So what is the topic today? The topic is the next boom. What are the biggest growth opportunities in clean tech now? We have a special guest to talk about this important matter. We have Colin McCormick and Levi Tilleman. Colin McCormick and Levi Tilleman have made a career on the leading edge of transformational technology and market trends in sustainability. Long before Tesla was a household name or renewables were a low-cost source of electricity, Tilleman and McCormick distinguished themselves as analysts and advocates for the emerging fields of renewable energy, electric cars, and autonomous vehicles. So, what new technologies are set to boom in the next 10 years? According to Tilleman and McCormick, active carbon removal, battery swap refueling for electric mobility, circular economy for the automotive sector, and heavy industry are emerging hotspots in the race to decarbonize the global economy. So we are here to hear our experts' views. So let's talk about our speakers. First, Levi Tilleman. Levi Tilleman is the author of The Great Race, the global quest for the car of the future, and a regular contributor to Wired, The New York, and The New Yorker, and other publications. He is also a former member of the Obama administration Department of Energy, senior advisor to Valence Strategic, and joined the startup Ample after working for the World Economic Forum, where he was leading on initiative on decarbonizing manufacturing, use phase, and end-of-life emissions of the automobility ecosystem. Secondly, the speaker, Colin McCormick. Colin McCormick is the Chief Innovation Officer of Carbon Direct, a US-based investment fund and advisory service firm specializing in carbon capture, carbon dioxide removal, hydrogen, and industrial decarbonization. He is also an adjunct associate professor at Georgetown University, where he teaches science and technology policy. During the Obama administration, he served as the senior advisor for R&D at the US Department of Energy and later helped found Valence Strategy. So let me talk about the timing. So usually we do in 1 hour, but because we have two speakers talk about very dense topic, I have reserved 1 hour and 30 minutes. We would like to finalize this webinar within this time. So the dynamic of this webinar is going to be discussion between Levi Tilleman and Colin McCormick. So we are gonna have a Q&A session after both speakers finish the discussion. So Levi, please take my, so now you have the floor. Please start the discussion with Colin. While you are talk to each other, I'm going to collect the questions, the comments, and address to you. And thank you again on behalf of the participants. We are here 8 p.m. I know that Levi is in San Francisco, so it's, correct me, I think it's a 3 p.m. in San Francisco, and Colin is in Washington, D.C., 6 p.m., 8 p.m. So thank you again for your presence here. So again, this is being recorded. So please, if you do not want to be on the video, please turn off the video. Thank you.
Muito obrigado, Sue. Muito obrigado pela oportunidade participar deste programa. And for that, I'm going to change into English for the rest of the presentation. I have to say, I'm a big fan of Sue Jung Ko and a big admirer of her initiative in bringing together different communities to convene on important topics, and I've been able to participate in a number of Sue Jung Ko moderated programs over the years, and she always does such a terrific job. So thank you for inviting me and Colin to join you tonight. This is also a little bit of a reunion for myself and Colin. Colin and I have worked together a lot over the years. I'm still a senior advisor to Valence Strategic, the consulting company that we founded, but for the past couple of years, Colin and I have been working mostly independently. So it's always a great opportunity to get together and chat about the different tracks that we're working on in the clean energy space. Colin is always at the cutting edge of things. So I'm going to give a short introduction, and then we're going to jump in, and Colin and I decided that we're going to take this opportunity to interview each other on some of the work that we've been doing. Before I do that, I will also mention that I see a couple of familiar faces participating in today's seminar. So we'll be talking a little bit about US politics and international politics, and I know that there are some very astute observers of the political and economic world who are also on the line with us today. So thanks for joining us. I have to say, this is a very exciting time in the clean technology space. There is so much happening. I have spent a lot of time on electric vehicles. 2 days ago, we were able to see President Joe Biden at Ford's headquarters talk about how electric vehicles are going to transform the United States automotive economy. Yesterday, Ford launched its Ford F-150 Lightning electric pickup truck. It was really exciting. And the day before, I don't know if any of you guys caught this, but apparently Joe Biden asked if he could drive the truck before it had been officially launched, and Ford obliged him. And so he got into a truck that was still all covered up to obscure what it was going to look like, because nobody had seen it in real life yet. And he peeled away from 0 to 60 in 4.3 seconds. I have to say it's pretty good for an old American president. We are going to see huge growth, not only in electric cars, but in so many of the industries that Colin and I have spent our time on in the last number of years. And I mean, at this point, it's been well over a decade for both of us. But the other hard truth is that the growth that we're experiencing now is nowhere near the scale that we need to see in order to solve the challenges that lie ahead. There is enormous international momentum, so that's from the Biden administration, and some really significant political moves, including Biden's American Jobs Plan, which proposes spending on clean energy at a scale that is literally an order of magnitude bigger than anything we've ever seen in the United States. That presents some opportunities. It also presents some challenges. For instance, for electric cars, Biden has proposed spending $174 billion to transition the United States automotive fleet, manufacturing capabilities, and refueling over from internal combustion engines to electric vehicles. We also saw a major legislative package at the end of last year that included big incentives for wind and solar. Now, at this point, it's unclear how much of Biden's ambitious climate agenda is going to become law. What is clear is there is an enormous appetite for change. And something else that is obvious is that everything that we are looking at accomplishing now isn't going to be enough. So there's going to have to be a lot more. And that's really what Colin and I are talking about today. What is that extra step that needs to be taken if we're going to decarbonize to a level to keep the globe within a relatively reasonable 1.5 to 2 degrees Celsius climate change scenario? So Colin and I are going to give you our perspectives on what that next step is, what the next big opportunities are in climate technology. As I mentioned before, we're friends, we're colleagues, we worked together in the Obama administration. We know a lot about the work that each other have been doing over the last number of years. But I think one thing that keeps our friendship interesting is Colin knows a lot more than I do about a lot of different things on his side of the ledger, and I know a lot more than Colin does and a lot of things on my side of the ledger. So that's why we like to talk to each other. So anyway, we're glad to be here, and we're glad that you guys are joining us for this conversation. And with that, Colin, I'm gonna kick it over to you, and you can sort of take the reins for the next 20 minutes or so.
All right, terrific. Thank you very much, Levi. And as Levi said, it's a real pleasure to be here with everyone today. This is a wonderful forum and a great opportunity to talk both with Levi and to hear about the questions and interests of the audience. So I get to play the role of interviewer. This is going to be a lot of fun. I'll get to ask Levi questions and he has to answer them. So I'm looking forward to learning a lot from this. So let's start out sort of at the high level here, Levi. You've certainly spent a lot of time thinking about big trends in decarbonizing mobility. So what are you excited about? What's really at the forefront of your thinking at the moment? And where would you imagine investments, patient capital investments? Basically, where's the next Tesla?
Well, I think that there are a few trends that excite me. One area that I spent some time on a couple of years ago, and am still somewhat involved in the space, though my current focus is really in electric vehicles, is micromobility. And the reason why I'm excited, but I'm not sure if you all are familiar with this term micromobility, but it refers to these small electric scooters, electric bicycles, electric three-wheel devices, some of them that only have one wheel and are gyroscopically balanced. And they may look like toys to some people, but I actually think they're extremely powerful tools for decarbonization. And the reason is that they fulfill a very important use case that today we use cars for in the United States and in a lot of developed countries. The reason why they're exciting from a climate perspective is when you drive around in a car, most of the energy that's going into that vehicle is being used to move around that heavy vehicle. In the United States, the average weight of a vehicle is about 4,000 pounds. Now compare that to a scooter, a little micro-mobility device. That only weighs 35 pounds. So you're talking 2 orders of magnitude less weight, 2 orders of magnitude fewer materials, an electric motor powered by a lithium-ion battery, which means it's very, very efficient. And you're using that tiny piece of equipment to move around a human that actually weighs more than the piece of equipment. So it's a much, much more efficient use of materials, battery materials, of steel or aluminum, and clearly of energy than either a standard vehicle is today, or an electric vehicle is, for that matter. The average Tesla weighs over 4,000 pounds. I don't think it's very surprising that a 35-pound scooter is a better environmental proposition for short trips than a 4,000+ pound electric car. So that's very exciting to me. I think circular economy is a huge opportunity. I spent about a year setting up an initiative for the World Economic Forum called the Circular Cars Initiative. And we took a pretty broad purview of what circular economy means with respect to automobiles. We looked at both the materials side, which means how do you manufacture zero carbon steel, zero carbon aluminum, zero carbon batteries? How do you utilize those vehicles efficiently and minimize the amount of energy that you're using during the use phase of those vehicles? And then how do you dispose of those vehicles at end of life with zero waste, and ideally taking those components and those materials and recycling them back into the automotive system. So rather than throwing things away, which is kind of the way we do things today with a standard linear economy, you are transitioning over into a circular economy. So I think that's very exciting. And then electric vehicles. Electric vehicles are going to boom, boom, boom. The transition that we're going to see there is going to be one of the most profound industrial reconfigurations of the last century. If you are interested in being involved in a growth industry, electric vehicles are a really good place to be right now. That's probably not news for anyone who's on the line.
All right, very interesting, and a lot of wonderful things to follow up on there. Let me start with the circular car. You mentioned the circular economy, and I know you've done a lot of work on this concept of the circular car. What does that mean? Does that mean that a vehicle could actually go through its full life and be entirely reused? What really is that, and what would that really mean in transportation?
Yeah, so the name circular car is kind of funny. I didn't choose it. It was the result of a bunch of European technocrats getting hold of the English language and applying it to a program that existed, though mostly in name, before I came to Switzerland. Sometimes we call it the zero carbon car because that's really what it is. The idea behind a circular car is that you have a zero emissions vehicle that produces zero emissions during the manufacture process and also zero emissions at end of life. And I think that it's an issue that the Europeans are looking at a little bit more seriously than Americans are today. With a standard internal combustion engine, the manufacturing emissions are between 18 and 20 some percent. So that's pretty significant if you're looking at the life cycle emissions. But we've been overwhelmingly focused on the use phase emissions. Now, that makes sense because the use phase emissions account for 60 some percent of life cycle emissions. But battery electric vehicles have a manufacturing carbon footprint that is 50 to 100% higher than an internal combustion engine vehicle. So as we electrify our automotive fleet, we need to think very carefully about how we're going to manage that increase in materials consumption and that increase in manufacturing emissions. And there's some strategies for that. The first is to be more efficient with how we use materials. So find ways to use fewer materials, less of what we've got. The second is decarbonize those materials. Steel, aluminum, batteries have huge manufacturing carbon footprints, but there are technology pathways that will allow us to get the manufacture of those materials down by, in some cases, 90 some percent. In some cases, actually, we can go carbon negative if you, for instance, use certain kinds of hydrogen or biomass in the production of these materials, and then you use carbon capture and sequestration. You capture those emissions at the source points, and you sequester those carbon emissions permanently. One of the most powerful things that we can do to decarbonize the automotive sector is to just utilize the automobiles that we have more efficiently. And this is really important when it comes to building a bunch of battery electric vehicles and putting them out on the road. As I mentioned, when you build a battery electric vehicle, you're looking at 50 to 100% higher carbon footprint than when you build an internal combustion engine vehicle. That said, when you utilize a battery electric vehicle, as long as you're running that vehicle on clean, renewable energy, the incremental emissions from running that vehicle are extremely low. That leads us to some kind of logical conclusions, which are we want to build as few battery electric vehicles as we can in order to replace all of the internal combustion engine vehicles on the road. And we want to run them for as many miles as you possibly can. That means we want to share those vehicles. So rather than having one person who owns one vehicle, have a group of people who use a vehicle through different new mobility business models. Ideally, you don't just have 1.3 people sitting in a vehicle, which is the average for the United States today, but if it's a 5-seater vehicle, you have 4 or 5 people sitting in that vehicle. Every time you put another person in that vehicle, you change the denominator on the emissions equation. So having 2 people ride in a vehicle is roughly twice as carbon efficient as having 1 person ride in a vehicle. And if you have 4 people ride in a vehicle, you're reducing those emissions on a per passenger mile basis by about 75%. So that is a really powerful lever that doesn't even require new technology. It just requires different business models and different use models. Finally, at end of life, there are a lot of systems that we can implement to recapture the value and recapture the embedded emissions in those vehicles. And rather than downcycling that steel and aluminum and other materials into construction and road aggregate and things that we could probably find less carbon intensive materials to support that kind of construction, recycling those materials directly into the automotive industry. So you essentially build a car, you use that car, and at end of life, you take the components and the materials that went into that car and you recycle them into a new car. That's kind of the ideal of a circular economy. So we need to address the carbon intensity of automobiles at every step of this process. And there is a huge investment opportunity there. I mean, the people who are successful at realizing this promise of the circular economy, they're going to win a big prize in the international economy. So it's somewhere that if I were investing some patient capital, I would focus very heavily on circular economy and the circular automobile.
Very interesting. Thank you. I guess I want to briefly dwell on one thing you mentioned there, which is from a carbon perspective. You said, I think, we want to build as few EVs as we can to replace all the internal combustion engine vehicles that are out there. But of course, if you're a manufacturer, that sounds maybe a little bit difficult if you're trying to sell EVs. So how do we square the circle there? What's the business model here for EV manufacturers to get out there with circular cars, low carbon transportation, and still make money while minimizing emissions as much as possible? How does that business model look to you?
Well, first of all, it is a challenge. It's a real challenge, and I think we don't want to downplay the significance of transitioning from a consumer business model to a user business model. But that is the answer. The answer is that we don't sell vehicles, we sell services. And we utilize our capital as efficiently as we possibly can. We find a way to tie the revenues and the profits of the automakers to the miles that they deliver, not the metal that they deliver. And today, they get paid when they build and they sell products. That sets up wrong incentives for the system that are, it is a baked-in environmental nightmare. There was a famous efficiency expert that you may know in the United States. His name was Lee Shipper. And he used to say that people don't want kilowatt hours and joules. They want cold beers and hot showers. And we have to look at things the same way for the mobility industry. In the future, we can't be selling people hunks of utilitarian metal. We have to be selling them miles and mobility and find more efficient ways to get them from one place to another place. And I think making that transition is going to be fraught for many automakers, but it is really the only solution to confronting the decarbonization challenge ahead.
Very interesting. I think that's, yeah.
There's a lot of that are going to have to be replaced. So if you make a good electric car, you're going to be selling a lot of vehicles going forward.
That's definitely true. Definitely true. Well, look, you mentioned the importance of using capital as efficiently as possible. And I think that's actually a great moment to pivot to what you're doing right now, battery swapping. Since, as I understand it, looking at conventional electric vehicle charging, you're looking at a very capital intensive prospect, putting a lot of chargers out there, having to think about grid issues. You've pursued a very, very different approach, this battery swapping concept that I think strives for much greater efficiencies of capital use. Can you talk a little bit about that? What is battery swapping, and what does it offer in terms of accelerating the adoption of EVs?
Yeah, so I think battery swapping is an effort to create a seamless transition for internal combustion engine drivers to electric vehicles. Today, the way that we charge electric vehicles requires a significant amount of learning, social learning, and a significant amount of infrastructure. You need a place to park at home. You need to plug in your vehicle overnight. If your vehicle runs low on energy, it's going to be half an hour or an hour before you get enough energy back into that vehicle before you can get back home. And the infrastructure to support today's system is really, really expensive. And the business models are just tough. It is hard to make money off of electric vehicle charging today. Battery swapping sort of flips this system on its head. It says, look, it doesn't make sense for this big, expensive piece of capital to have to be sitting around and charging when we could take one piece of that big, expensive piece of capital out, separate it from the vehicle, and use it for a whole bunch of different things. And by the way, when the car comes back, we can charge it in 5 minutes rather than 45 minutes. And the way that we do that is it's called battery swapping. You basically remove the depleted battery from the vehicle and you plug in a charged battery. The interesting thing about battery swapping is, the first thought that most people would have when they hear about the system is, wow, that's going to take a lot of batteries. The truth is, it doesn't take a lot of batteries. It takes, in aggregate, probably many fewer batteries than you would have in a non-battery swap system. And the reason for that is people desperately want to avoid charging their electric vehicle while they're on the road. That means that they're demanding battery packs that are bigger and bigger and bigger. So now you're seeing electric vehicles that are advertising 500-mile battery packs. And the only reason we need those big battery packs is because people just don't want to charge when they're out driving because it's a pain in the butt. If you can instead swap your battery in 5 minutes, there's no reason that a 250-mile or a 200-mile battery pack won't suit your needs just fine. So you sort of trade some of the battery in the car for batteries that are installed in these swap stations and can be used to absorb renewable energy when it's available, dispense it very quickly when it's needed, and then swap into vehicles very quickly. Now, there's something else that is exciting about the way that we're doing battery swapping at my company, Ample, which is rather than using big facilities and big robots to swap out big battery packs, we have these small battery swapping pods that use small robots to swap in and out lots of small battery modules that kind of mix and match like Legos. They stack on top of each other. And this means that they can fit into any kind of EV. You don't need to have a specific form factor to the battery pack that either you build the car around or you build the battery pack to conform to the car. Instead, you have these smaller batteries that you can stack into the geometry of the vehicle as it exists today. And then, the second thing that's really exciting about what we're doing is that it allows you to vary the size of the battery pack dynamically. So on a day that you are driving a long distance, 300 miles, you might want a 300-mile battery pack. But on a normal day in the city, there's no reason why you need a 300-mile battery pack. So we can give you a 120-mile battery pack, which is probably going to last you the better part of a week. For me, it certainly would, living in San Francisco. Lots of flexibility is enabled by modularizing the battery swap system. Lots of flexibility is enabled by using battery swap instead of chargers. There's some more technical issues that I could get into as to why chargers are challenging for integrating renewable energy and why they actually are a little bit destabilizing for an electrical grid, whereas battery swap systems, which have these big pods of energy storage that can be used to absorb electricity whenever it's available, and then even feed energy back into the grid if the grid needs more energy. They sort of shore up the system. But I'm not gonna dive too deep on that right now. Just to say that it works well for people who don't have access to a garage with overnight charging. It works well for people who have high mileage use cases for vehicles. And I think that something like this is going to be necessary if we're going to get to 100% electrification. China is now, they're prioritizing battery swap vehicles over traditional electric vehicles. They just released a new set of subsidies. Basically every major Chinese manufacturer is doing battery swap today, despite the fact that China has 16 times the number of DC fast chargers that the United States does. They have 80% of the fast chargers in the world. And with that network, they've realized that fast charging, unfortunately, is not the solution. They're going to need battery swap to electrify their entire fleet.
Wow. It's very sobering. So who else is doing battery swapping today? In China, it sounds like it's a big deal. Where else is this happening?
Renault just made an announcement that they're looking at rebooting battery swap. We have a lot of conversations with a lot of automakers, and there is a surprising amount of research and development going into battery swap just underneath the surface of a lot of automakers. In China, I mean, every major automaker is Beijing Electric Vehicle, the Shanghai Automotive Industrial Corporation, BYD, NIO, obviously. If you're a car company worth your salt in China, you're Geely, you're investing heavily in battery swap infrastructure. And the reason why is it is so much more capital efficient than charging infrastructure. NIO has built 180 battery swap stations now. That doesn't sound like a lot, but I've done the math, and between October and March of last year, those 180 battery swap stations provided more electric miles than America's 13,000 fast chargers did cumulatively. That is a wild number. It's the same reason that in America, we only have 100,000 gas stations and falling, but we use that to supply energy to 270 million vehicles. It's a very time efficient, space efficient method of refueling a vehicle. And battery swap is essentially a gas station for an electric car. So very powerful technology, very powerful business model. And I think it's going to be the dominant business model for refueling electric cars within 10 years.
Well, this is fascinating. Look, I'm supposed to stop and have you interview me, but I need at least one more question. So if you don't mind, what does battery swap look like from the consumer's point of view? So I drive in 5 minutes, but not only just at that moment, I'm getting a new battery. Does that battery get upgraded over time? What does this feel like as a driver?
Those are great questions. There's sort of an immediate perspective, and then there's an ownership perspective and a long-term perspective. The immediate perspective is it looks almost exactly like driving a gasoline-powered vehicle. You roll into the swap pod, we swap your battery, you roll out with a full tank of electricity in this case, not gasoline. And it's funny, we support a fleet of Uber drivers that are using our technology here in San Francisco. None of them drove EVs before coming to Ample. They all drove gasoline-powered vehicles. And for them, it was kind of a seamless lateral shift to electric. And that's what we need to enable. Now, from a long-term perspective, there are some exciting elements of battery swap. The first is you don't have to buy a battery. So that saves you a lot of money up front. You also don't have to worry about your battery degrading. In fact, your battery is going to get better over time because battery chemistry is going to get better over time. So the range of your electric vehicle is actually going to increase. And rather than having to essentially throw away your electric car after a certain number of miles or a certain number of years, kind of like we do with our iPhone as the battery from the iPhone degrades, you'll be able to use that vehicle for a long time, a really long time in some cases. So it's really attractive from a fleet's perspective. It's also really important that fleet drivers have access to something like battery swap, because a fleet driver puts a lot of miles on their vehicle. You're talking about 3, 4, even 5 times the number of miles that a standard consumer does in a year. An Uber driver doesn't have the time to wait around for an hour to charge their electric vehicle. That's just not an option for him or her. If he or she does that, they're going to be sacrificing about $5,000 of income a year. And that's from someone who makes $40-some thousand a year on average. That's not tenable. So it democratizes electric vehicles. It opens up electric vehicles to a much broader segment of the population. Today, electric vehicles work really well if you're an affluent suburbanite with a 2-car garage and a place that you can plug your electric vehicle in overnight, and you're not going to go too far. For everyone else, battery swap is a really good option. So anyway, Colin, I'm going to take your invitation to wrap up there, and I'm going to turn the tables. And I'd like to talk to you about some of the work that you're doing today. Maybe you could just sort of start with your potted pitch for the company that you're doing most of your work with today. What do you guys do? Why do you do it? And then after that, I'd like to ask you about some of the specific technology solutions that you're working on.
Absolutely. Well, so I am Chief Innovation Officer with Carbon Direct. We are an investment fund, as you heard earlier, and also an advisory services firm. So on the investment side, we are looking at sort of Series C companies in the carbon removal, carbon capture, hydrogen, and industrial decarbonization space. There is a huge explosion of innovation in this space, and we're really excited to be in the middle of it. We think this is a big deal. We think these are the kinds of companies that are really going to boom over the next decade. On the advisory services side of the firm, what we do is we have a very deep bench of scientists and engineers who know a lot about these carbon removal technologies. I'll talk about them later in the
where do scientists and engineers come from?
Well, mostly academics. So we have I think we're up to about 30 people on our science advisory team coming from Columbia University, UC Berkeley, University College London. We're a global team who have been passionately working on these topics of carbon removal, and these folks are all very excited to get to really sink their teeth into these investment opportunities now.
And my understanding is that you have kind of a lot of heavy hitting expertise from places like the US National Labs and people who have been dedicated to these technologies for decades, and they understand them inside out. And now they're getting to apply that expertise to the private sector. Is that right?
That's right. What we're seeing at the same time as these technologies are really emerging from labs and making a commercial splash, we're seeing a growing demand from private sector companies like Microsoft, probably the best known example, to achieve net zero emissions targets across the corporation, and are discovering that doing that is going to require activities like you've been talking about, driving down the emissions from transportation. It's going to require solar, wind, renewable electricity, but there's going to be a chunk of emissions, maybe 20%, that they can't get rid of. They can't eliminate through those measures. So what they're interested in is finding ways to balance the books, get down to net zero, by actively scrubbing carbon dioxide out of the atmosphere. So these companies like Microsoft and others come to us to ask, how can we do that? How can we credibly use technologies that remove enough carbon dioxide from the atmosphere that our net emissions get all the way down, not to 20%, not to 15%, but actually get all the way down to true net zero, all in.
So actively scrubbing carbon out of the atmosphere. To me, when I hear that, that brings to mind all sorts of different solutions. Some of them very technologically complex. Some of them sort of more traditional, along the lines of planting a garden. Maybe you can spell out for us, what technologies are out there, what technologies are going to scale, which ones you're the most excited about, and maybe we can dig in on some of the details of a few of the more interesting avenues.
Sure. Well, look, the first technology everyone looks to, of course, is trees. We've all seen these ideas floating around. Look, plants, trees, scrub carbon dioxide out of the atmosphere. That's what they do. And so why don't we go out on a massive campaign of planting trees? Annual plants, crops that herbaceous plants that lose their leaves every year are not a good bet, because that's only a year's worth of carbon storage. But a tree that might be 100 years old is storing a lot of carbon in its wood, in its trunk, and in its roots below ground. So that's certainly the sort of the technology that many people have looked to. And in fact, when you look at current practices, you see carbon offset markets around the world, where companies buy carbon offsets by preserving forests or potentially planting new forests. It's a great approach. I love trees. I hope we plant millions or billions more trees. Unfortunately, there are some drawbacks. The first is that we are seeing through the impacts of climate change, the changes to the climate that are already occurring. We are seeing increased threats to forests. We saw massive wildfires in California and others. We're going to see them again this summer. Australia is another horrible example. Recent research has shown that the Amazon basin has unfortunately probably turned the corner from being a net carbon sink into being actually, on balance, a net carbon emitter because of land use change, because deforestation and land use change.
Can I ask, when you have a forest fire, what is the scale of the carbon that is emitted there? I mean, is that similar to all the cars on the road? Is that, I mean, what does that do to us when we have a big fire year in California?
Yeah, it's a big deal, unfortunately. So last year, the equivalent carbon emissions from the fires in California more than wiped out all the carbon emission reductions through all the efficiency and other programs that California has implemented.
Wow.
So in other words, all of that was erased by one bad year of fires. And we're going to have bad years of fires pretty much every year now.
That's so sad.
So yeah. So again, I want to emphasize, I love trees. I hope we plant a lot more trees. There are many benefits. But when we're looking at the scale of removing carbon dioxide from the atmosphere, trees will not be sufficient. And unfortunately, they're probably going to be less and less reliable as a long-term storage of carbon into the decades in the future.
So what other options do we have?
Well, the good news is we have quite a few, but as you say, they get more and more complex technologically. To sort of step up the ladder of technical complexity, the next thing obviously is looking at soils. Soils hold a huge amount of carbon. Unfortunately, human activity, human farming, has disrupted soils around the world.
And Colin, can you explain, when you say soils hold a huge amount of carbon, how do they hold that carbon? How does it get there? What is that carbon?
Yeah, sorry. So plants, as they grow, leave carbon in the soil in a few different ways. One of them is they leave their roots in the soil. That's obviously carbon that the plant grew. There are more complicated biochemical ways in which plants inject carbon into the soil in cooperation with soil funguses. I won't bore people with the biology details, but essentially plants are injecting. We'll get back to some of that in a minute.
Yeah.
In that space, the kinds of things you can do range from very simple things like cover crops and different agricultural practices, no-till ag, all the way up to some really crazy biotech. There's some labs pursuing genetic engineering of plants that would have them inject new forms of carbon into the soil, effectively cork that lasts forever, never gets broken down. So we see a whole range of these ideas in agriculture, from very simple to very, very technologically advanced.
And how much carbon can we sequester using soils, and where would we sequester this carbon? What are the geographies?
Well, look, the geographies are anywhere agriculture is happening, and that's obviously global. How much we could sequester is potentially billions of tons. We haven't talked yet about how much we need to sequester, but billions of tons a year matters. The real challenge here is that most agricultural soils, the decision making is smallholder farmers. You've got to change a lot of practices, and you've got to convince a lot of farmers that this is in their interest. And you also have to rely on those practices that injected carbon into the soil continuing into the future. Humans have messed up soils badly for the last 100 years. So it's not unreasonable to think that if we subsidized or paid for soil carbon storage, coming back in 20 years, that farm may have changed its practices, and some of that carbon may have come back out of the soil.
And so is that something that we see on the horizon, people being paid to sequester carbon in soils through agriculture?
Absolutely. We're seeing it definitely already in the US, actual programs as well as major new proposals. There's a lot of political value in it. It allows agricultural communities to earn revenue and improve their soils. More carbon in the soil essentially always improves your soil quality and your yields.
So let's raise our gaze a little bit higher and examine some of the other opportunities beyond soils. What else is out there, and,
sure.
and what are you excited about?
Well, the one that gets a lot of attention, and I am very excited about, is known as direct air capture, or DAC. Direct air capture is the idea that we can use chemical processes that we actually have used for almost a century in other industries. We could use those chemical processes to react with CO2 in the air and separate it out of the air and store it. It's very similar in some ways to the idea of carbon capture on a smokestack, except in this case we're not scrubbing carbon out of flue gas, out of what's coming out of the power plant or the smokestack. We're actually going to the open atmosphere and scrubbing that carbon dioxide back out.
And why would we do that rather than grabbing that carbon at the smokestack where it's super concentrated and potentially easier to get a larger amount of that carbon separated from the rest of the gases?
Yeah, look, I think that's a great question. And the answer basically lies in engineering versus politics. So if you were an engineer, the first thing you do is exactly what you're saying. You would go to every single smokestack in the world and you would bolt on a carbon capture device and you would scrub out that high concentrated CO2. The problem is that this world is not made of engineers. This world is made of people who don't necessarily want you to come to their factory and bolt anything on the smokestack. DAC has the advantage of being able to work anywhere in the world. All you need is the atmosphere. Now you need energy, you need a place to put the carbon dioxide, so I don't want to be too flippant about that point. But you can locate DAC essentially anywhere, meaning that you don't have to ask permission. You can clean up the atmosphere without having to get cooperation across borders, cooperation across sectors. You can do it in a way that can occur much more quickly than cleaning up every smokestack in the world.
So I want to hit on two more areas of your expertise. The first is using weathering to pull carbon out of the air, and if you can kind of explain how that process works. And then I want to move into I think what is the other strong argument from my perspective for direct air capture, which is going carbon negative. And it seems like one of the other benefits of direct air capture is once you shut down all the smokestacks, we're still going to have to pull a lot of carbon out of the air. So maybe if you could talk a little bit about why we're going to have to continue pulling carbon out of the air, even once we've shut down all the smokestacks, and what the scale of that challenge is. I mean, how big is this industry going to be? Is this really the next prize in terms of investing in the clean technology space?
Yeah, I think this is a really good question. Let me talk about the scale first. So one place to start on that is that humans over the course of the Industrial Revolution have emitted something like 2,000 or 3,000 billion tons of carbon dioxide into the atmosphere. And very roughly, that's about as much carbon dioxide as we're going to have to pull back out of the atmosphere to achieve a stable climate. So 2,000 billion tons is a number that's almost impossible to conceive of. To put it into kind of an annual rate, the best models seem to suggest we're going to have to get to effectively net zero emissions by something like mid-century, 2050. And we're going to have to scrub out probably tens of billions of tons a year for the foreseeable future. So this is a gigantic
of tons. If you put that in liquid form.
The best
compared
comparison,
to the oil industry.
Yeah, the oil industry we think about in barrels, right? But if you look at tons, the oil industry produces about 5 billion tons of oil every year. So if we're going to scrub 10 billion tons of CO2 back out of the atmosphere every year, that industry, that carbon removal industry, will be twice as big as the oil industry is today.
And in fact, it may be significantly bigger because it's easier to put a straw in the ground and pull oil out than it is to gather up your carbon dioxide and pump it back through that straw to get it back down.
Certainly true. That's certainly true.
Yeah, super interesting. So maybe you could talk about weathering and that approach and how promising do you think it is? What are the prospects there?
Yeah, this is another separate approach to removing carbon dioxide from the atmosphere known as weathering, or you'll also hear mineralization. The idea here is that natural rocks, natural minerals that occur in enormous amounts in the Earth's crust naturally react with carbon dioxide. In fact, if we could if we could fast forward over the next 100,000 years, we would watch those rocks naturally react with carbon dioxide and gradually, over 100,000 years, bring down the carbon dioxide level in the atmosphere. So the idea of weathering or mineralization is to speed that process up, is to get those rocks, expose them to carbon dioxide, and have them form new minerals, new carbon minerals that are solid and that lock that carbon away in another rock form.
And what does that look like? Does that look like a big cement mixer? You kind of grind these things up and you turn them with carbon dioxide, or what is the actual physical form of that?
Yeah, there's sort of two basic approaches. One is you get a bunch of rocks, you have to crush or pulverize them to give them get a lot of area so that a lot of air can react with them. Then you have to get rid of all the minerals that produces. Maybe you scatter them across cropland. Maybe you do something else. The other idea that's been very interesting is you go to places where that crushing has already happened, namely mines. And it turns out that a lot of different kind of mining, nickel, copper, platinum, the tailings that were part of that mining process are sitting in enormous piles by the mine, and some of them are actually quite good for absorbing carbon dioxide from the atmosphere. So one very interesting direction to go here is find these tailings. This is work that is already being researched, certainly, and find ways to expose them to air more aggressively and scrub out that carbon dioxide almost for free, because those big waste tailings piles are just waste, and they've already been crushed up and pulverized and ready to go for this carbon reaction.
That is fascinating. Let's talk about one more technology, and then I think I'm going to wind things down and open it up to discussion in just a second here. But BECCS, what is BECCS? Why is it important? How could it factor into the future? And what's the potential scale of that industry?
Yeah, BECCS, let's see, bioenergy with carbon capture and storage, BECCS, is an idea that's been around for a while. The basic idea is you would take biomass, that could be sugarcane bagasse, that could be wood pellets. You take it to coal-fired power plants and you burn it in the power plant instead of coal. And then if you just do that, you have a little bit of carbon removal benefit afterwards when, in theory, those plants regrow, they scrub the carbon dioxide back out of the atmosphere. It's sort of like a future carbon benefit. If you also put a carbon capture device on the smokestack of that power plant, then the math works out that you actually get net negative. So that's a great idea. The real problem that's occurred on this is that it's not competitive with other electricity generation. So this relies on keeping old coal-fired power plants going with a more expensive fuel at the same time as solar and wind costs are plunging, and the competitiveness angle just doesn't work. So there's been a lot of trouble in making these BECCS ideas move forward in the face of plunging renewable electricity costs.
So I actually have one last question before we move on for you, which is, all of this seems like it not only rests on a foundation of, but it can only grow on a lattice of policy. If you don't have the policy to support these industries going forward, they will not grow, they will not boom, and we will not solve our carbon challenge. If you do have the policy in place, however, these are going to be some of the biggest industries in the world, and those industries will have to grow very, very quickly. So what are you seeing from a policy standpoint? Are people preparing the necessary policy frameworks that will enable these industries and technologies to grow? If you were king of the world, what would be the first 2 or 3 things that you would do to make sure that we can build up the carbon removal industry that's going to be critical to addressing the climate challenge ahead?
Well, you're absolutely right. Policy is vital here. We are seeing some very positive signs when it comes to policies, particularly around carbon pricing. In the US, we have the 45Q tax credit, which is something like $50 a ton of CO2. That's a good number. Canada recently announced it wants to raise its carbon price at perhaps as high as $170 per ton of carbon dioxide. That's a lot of money. We're seeing the Europeans talk about big numbers as well, raising the price that subsidies would pay anyone who captures or removes carbon dioxide. China may be very interesting as well with the carbon trading scheme that's recently been launched. So around the world, we see, I think, these positive changes in policy support for carbon dioxide removal and reduction. I think that's very exciting. I think that means that these technologies are going to have a market, a big market, that's going to get them down these technology learning curves to get cheaper, faster. And I think we're really seeing the onset of just a huge boom in the market across the board on these technologies.
Well, thank you, Colin. You are truly one of the foremost experts in the world on these issues, and it is a real pleasure to chat with you and to hear your insights and to gain from your expertise. And I look forward to doing this again sometime in the near future, but I want to make sure that we can bring everyone else into the conversation. So Sue, do you want me to moderate this section and we can sort of take questions from the audience, or do you want to play moderator now?
Let's see here. So we have first of all, thanks so much for your great discussion, Levi and Colin. I got several messages actually on my smartphone. So I'm going to, yes, everybody is very excited, and especially as you know, Brazil is a very big country for agribusiness. So you mentioned something that touches agribusiness. So probably we actually have participants who work with agribusiness here. And also I would like to mention that we have the participants coming from different regions of Brazil, from South, Northeast, West. So I'm very excited to have them with us. So I have three questions here. I would like to address these questions so that you can just feel comfortable to answer. And also let me moderate here, Levi, Colin. People are processing a lot of new information and new ideas that you gave. So people sometimes need some time to process and make comments and ask the questions, okay? So the first question is, how's the battery recycling process? And are they already recycling it? You want me to read the three questions and answer, or would you like to answer one by one? What do you prefer?
Sure. Why don't we read all three questions, and then Colin and I can divvy them up?
Okay, because one thing leads to another for the discussion. So the second question is, will the city mobility be concentrated on electric to wheels and on tracks too? And that's the second question. And the third one is quite broad, but I think it's always good to hear your the expert's view. What is the big challenge for the popular access to renewables and sustainable solutions?
So, Colin, why don't you take that third one, and I can take the second one and the first one. And I'll jump in with the second one first. I think that in an ideal, so first of all, this is a very complicated problem. There's not a one-size-fits-all solution. And I know that it's almost a cliche to say that, but it is true. That said, I think that it is a goal that we should have as a society to move as many of the miles that are currently provided for using automobiles to light electric vehicles, two-wheelers, three-wheelers of different shapes and sizes, and to use those light electric vehicles, those micromobility devices, to access what we call trunk line transportation, things like trains, bus rapid transit systems that can take us farther, faster when we need to go longer distances. And I think in an ideal world, you would have a lot of people using very light, very efficient electric vehicles. Those would funnel in to trunk line transportation that would connect major population centers or would get us across the city, you know. So if I needed to go down the peninsula, I live in San Francisco, if I needed to go down the peninsula, you know, I could get on a train or I could get on a metro or a bus rapid transit, and then get off with my scooter or with my one-wheel device and take that the mile or 2 or 3 that I would have to travel to get to my ultimate location. Now, there are various issues. It rains. People have dogs. People have families. Those all make it difficult to take a micromobility device. And I think that we have to be cognizant of those complexities when we're thinking through the reality of this transition. But none of those factors obviates the importance of making this transition to micromobility devices to the extent that we possibly can. So we need supportive policy. We need to take some lanes away from cars to give them to bicycles and micromobility devices. I like to think of it almost like bandwidth on the internet. If we give micromobility devices the bandwidth, if we give them really good lanes that only they have access to, so people don't feel like they're going to get mowed down by a dump truck or by a mom who's distracted by her kids in a minivan, then people will use those micromobility devices, and you'll see more and more of them. And we need to have supportive policy for micromobility devices. Batteries. So battery recycling is very challenging. It's getting better and better. I think that there are sort of 2 steps before that are really important to talk about. The first is to just use fewer batteries where you possibly can. And this gets back to our idea of modular battery swapping, where rather than putting a 500-mile battery in each vehicle, you put a 150-mile battery in each vehicle when it's in the city. You swap it out for a 300 or 400-mile range battery when people need to go farther. And then you swap that battery in 5 minutes if people need to refuel while they're on the go. That enables a system that uses many, many, many fewer batteries on the aggregate. And it's a little bit paradoxical, but it means that you get essentially all of the utility of a system where every car had a 400-mile range battery, while only having the equivalent of, let's say, 200 miles of range for each car that's driving around there. So that's really important. The second important thing is to make sure that we are efficiently transitioning those automobile batteries to a second life when that becomes necessary or reasonable. The nature of a battery is that it's very big and it's very heavy. And once it reaches a certain level of degradation, it doesn't make sense to carry that big heavy battery with you in an electric vehicle, because you're essentially lugging a bunch of weight that you don't need to be lugging around. And so in an ideal world, you want to take that battery out of the car once it reaches, let's say, 85% capacity, and you want to move it into a second life where it can be used for storing renewable energy, as power backup for a home or for a commercial facility. And modular battery swapping is really good for that, because we can individually monitor each one of these little battery modules that goes into the vehicle. And once it gets to 85%, we just take it off the shelf. We plug it into essentially a Tesla Powerwall, but our own version of that. And we sell it to either a commercial facility or a residential customer as power backup. It's really easy, really fast, and really efficient to move those batteries into a second life. So you want to build as few batteries as you can. You want to extend the life of those batteries as long as possible to use them efficiently, both in the vehicle and also in their second life application. And then beyond that, you want to recycle batteries. And I would say the most promising work that I have seen on battery recycling to date comes from Volkswagen. They're claiming some pretty extraordinary efficiencies with respect to the amount of material they're able to recover in their battery recycling processes. I think it was over 90% of materials recovery. Now, I don't know how energy intensive that process is. I know that some battery recycling facilities, they say that they can actually power the facility just with the residual energy that is in the batteries that they are taking in for recycling. But what I have seen is that their reclamation rates for the materials that are in those batteries are much, much lower than what Volkswagen is claiming. So it is happening. It's somewhere where we need a lot of innovation. I would plow a ton of money and a ton of resources into this if I were if I were managing a big government R&D portfolio. And I would also use things like the Loan Programs Office at the US Department of Energy to fund these facilities, because we're going to have a massive number of batteries that need to be recycled within just a few years. Colin.
Sure, lots of very interesting things in what you've just said. Look, regarding that third question, I think there are many people all over the world who are asking these questions about sustainability, about the future of the Earth's climate, and about what they can do, what they personally can do. Probably the biggest barrier there is a lack of knowledge and a lack of understanding where emissions come from and what kind of actions individuals can take to affect those emissions. Electric vehicles are a wonderful approach. Better access to renewables is a wonderful approach, but many people don't necessarily have access to that, or it's difficult for them to access that. I think one of the most effective things people can do, though, is talk more about their desire for sustainability, for emissions reductions, and push particularly companies, but also governments, to do more. In our business, we work with more and more multinational companies that have set net zero targets. They haven't set net zero targets because governments demanded them, regulated them to do it. They're setting it because their customers and people out there are demanding it of those companies. So those activities do matter. Pushing companies and governments to take action really does matter. And I would say that is a key activity that many people globally can take.
So we have about 16 minutes now. We have quite a dense question for Levi, one question for Levi, and one question for Colin to answer. So let's answer those questions and see if we have some time for the final comments, okay? So first is the question for Colin. Which initiatives have you seen for soil improvements in terms of carbon? Which policies are being discussed in the US or any other places?
And can I make a comment on that question before Colin jumps in? I believe that's from Gabrielle, right?
Right. You wanna give a background on this?
Yeah, well, I think it's interesting.
Facilitate Colin's answer. Yeah.
So Gabrielle's family they have big farms, big ranches in Brazil. So this is very personal for him potentially. So, if we give Gabrielle a good answer, he might go sequester a bunch of carbon for us. Who knows?
Super. Hi, Gabrielle.
Welcome,
Fantastic.
Gabrielle.
Welcome.
Thank you for inviting.
Well, thank you for the question. So obviously soil carbon is different if you're growing crops versus ranching. We've seen initiatives in both. On the crop side, you see things like no-till agriculture, cover cropping strategies. Cover cropping also is very relevant in ranching. There are interesting ideas about intensification and livestock rotation. I don't know that I want to get into the guts of those here, but in the US, there is an active discussion about whether those could be subsidized. There are real questions about how you measure the impacts of those, because we don't have very good methods right now of validating how much carbon is actually being added to the soil. That is holding up a lot of policy movement, because you definitely have this skepticism from the bureaucracy that real carbon storage is happening. So the debate in the U.S. is focused, at least in part, on that question of how can we measure and validate the additional carbon that's happening here. The second piece of it is longevity. So we definitely see some programs that require landowners to affirm or attest or promise that they will continue practices for 20 years, 30 years. That's accepted by some people as reliable, but there are questions raised by others whether that's actually going to be the case a decade from now if the land use and practices are going to continue. So maybe I'll pause it there, and I'm happy to connect later if you want to talk more details.
Okay, so the next question, this is the last question addressed to Levi. So Levi, I have been studying these few days regarding EVs and the impact of battery production in this industry. The main issue I have noticed is regarding the main metals to produce the batteries, cobalt and nickel. Is there enough of these metals in the world and easy access of this metal to produce all these batteries? What I have been reading is that most of these miners are located in specific places such as Republic of Congo or Chile. So it seems that we are dependent on these countries. Also, one of the metals to produce cobalt is copper, which is getting harder and harder to mine good quality copper.
Mm-hmm. So there's a great quote about hydrocarbons, not batteries, that I sometimes think about when these issues come up, which is oil is discovered in the mines of men. What does that mean? Obviously, oil doesn't exist in the minds of men, but there have been numerous times, many times over the last 100+ years that people thought we were running out of oil. And in fact, there were hydrocarbons to be had. It just required us to move to different geographies, to pioneer new techniques of drilling, to pioneer new extraction methods. And what we find is that as scientific frontiers advance, there is almost always more oil available out there. We're going to run out of space in the atmosphere to put this carbon much sooner than we're going to run out of thing about batteries, which is that batteries are discovered in the minds of men. Obviously, there will be short-term bottlenecks with respect to a variety of different metals. I think that the ones that were mentioned, cobalt, nickel, copper, those are all important areas for investment. And I don't think we're seeing enough investment, quite frankly, in mining and recovery for a number of those different kinds of metals. So there may be bottlenecks. That said, the speed at which battery technology is advancing is breathtaking. And companies, research laboratories around the world are innovating past many of these bottlenecks. So cobalt, for instance, a lot of companies are not using cobalt in their batteries anymore because there are huge labor issues with respect to cobalt. So if you go down to the Democratic Republic of Congo, the mines in which they're producing cobalt have just horrendous labor conditions. And so a number of the Japanese automotive companies have come up with new battery chemistries that don't really require cobalt. You see different preferences for different battery chemistries in different parts of the world based on specific needs, and also national strategies with respect to energy security and also the emphasis on safety as opposed to utility in vehicles. So I think that there is going to be quite a bit of dynamism in the space. I think that battery chemistries are going to change continually. One thing that is, sorry to plug our company again, but one thing that's kind of cool about what Ample is doing is that generally speaking, when you design an electric car, you need to design it specifically for the battery chemistry that you're using, because it produces energy at a specific voltage, and there are a number of other variety of characteristics that you have to design your systems to. Ample's modular batteries have a layer of power electronics that allows them to adapt the voltage and the output to the vehicle that is using the battery. And that means that we can use any battery cell chemistry, and we can plug that battery into any vehicle once we have installed our adapter plate in that vehicle. So the idea here is that you don't have to be constrained by a specific battery chemistry anymore, that you can use different kinds of cells, and those cells can be plugged into different kinds of vehicles. And I think that gives you a lot of degrees of freedom with respect to some of those issues. But those are serious issues. They're important issues. There will be bottlenecks. I think nickel, copper, cobalt, yes, those are all important areas for investments. And quite frankly, I think that a lot of auto companies are going to have trouble if they haven't secured their access to cells and their access to those rare earth elements. Colin?
I just want to make one comment on nickel in particular. So I mentioned, we talked about weatherization and carbon mineralization. It turns out that nickel mines have fantastic associated tailings for carbon mineralization. So one of the areas we're thinking hard about is, are there synergies here, opening or expanding nickel mines, but actively using the tailings from that for carbon removal to try to reach net zero or possibly net negative production of minerals. Early stage, but I think those are the kinds of creative ideas and connections that are really gonna help us in this space.
That's really fascinating.
So Levi and Colin, we have about 7 minutes, so I'll ask you to make the final comments considering my question, because I think I deserve to ask one question. So the question is, when you make the final comments, which is very important to mention here, is that we have the leaders in our audience is composed of the leaders from different sectors. I didn't mention that because I just focused on where they are coming from, but actually we have the participants from the venture capital, startup, asset management, entrepreneurship. Even we have a public official here working for the government. So we have a very lawyers, we have the bankers, so we have the diverse type of the audience here today. So, and they care about Brazil, okay? Every single person cares about their family, their community, and the country. So I don't know if Colin has ever been to Brazil. Please, I believe that you have already taken the vaccine. So in the future, you guys are all welcome to visit us here in Brazil. And so when you make the final comments, I would like to also hear that. What kind of the vision that we should have, considering each person, not in terms of the Brazilian, right? So that we can live more positively. I see a bright future in 10 years, because the topic was about big trends in 10 years from now. So what kind of the ideas, visions that we can have so that we can live a more happy life?
Colin, should I jump in? So
why don't you go ahead?
I think it's important for us to address these challenges at a social scale. That is unfortunately a slightly depersonalizing way to look at things. But my perspective is that when companies turn the responsibility back on humans, individuals, and they say, it's your responsibility to drive a low carbon car, or your responsibility to live a low carbon lifestyle, the system is so stacked against us, it's very hard to do that. And unless changes that we need to in order to allow this transition to happen. Now, that said, structural change requires a lot of work by a lot of individuals. And I think sometimes it requires you to fight against a system that is inherently hostile to that change, because there are a lot of vested interests there. And the willingness to, as a famous American politician, John Lewis, used to say. He was a great civil rights leader. He said, make good trouble. That is important. You need to be willing to make good trouble. What does that mean? That means you have to sometimes draw outside the lines. You have to go up against the system and raise your voice as a leader and say these things need to change, even if you get some blowback for that. Because unless there are leaders who are willing to stand up and stand out and take some risks in order to pull society forward, then society won't change. And I think that the people who are in this group are probably in a very good position to make that kind of good trouble. So that's what I would suggest. Don't be afraid. We have a lot of great opportunities that are in front of us, and if you're willing to take that bull by the horns and make good trouble, then you can be part of the solution in a really significant way. And I think I've been fortunate enough to see that throughout my career. A lot of Collins and my friends are now leading clean energy policy for the Biden administration. We all sort of went through the last 4 years where Trump was really fighting against the work that Colin and I have been dedicated to for our whole lives. And nonetheless, we made extraordinary progress. And now there's just so much energy. We are ripped and we are ready to go. And this clean energy economy is about to take off in a really exciting way.
Well, I agree with all of that. Look, I guess I'll just briefly comment that we're now at a point where taking risks in a leadership position for climate benefit is a winning strategy. If you are in a leadership position and you're not thinking about climate, you're not on the right side of this. We see more and more leaders in corporations in a number of sectors that are demanding change within the organization and taking risks to benefit the climate, and those are wins. The stepping in that direction is going to result in benefits for not only the world, not only your community, your family, but for whatever professional role that you are in as a leader. So I hope people remember that this is an important time. We are really on the cusp of this, and climate positive action is a winning strategy.
Okay, so again, we are very punctual. We have 1 minute to finish our webinar. It's 8:29 here in São Paulo. So once again, Levi, Colin, I know that so I need to have dinner, and Colin, I think so, and Levi have a few hours to work still. So I would like to repeat this webinar with other topics, especially about the international relations. I know that both of you have this very interesting background in international and global relations. We'd like to learn from you. So again, thank you so much for all the participants who stayed with us for 1 hour and 30 minutes. This webinar was recorded, so we are going to share the recording after this webinar. So let's keep in touch, Levi and Colin. And again, if you want to come to Brazil, the doors are open as soon as everything is allowed. So have a good evening over there and good afternoon, Levi, and boa noite a todos. Até a próxima.
Boa noite.
Muito obrigada. Tchau, gente. Tchau, tchau.